So in this lecture we will see directional relay. So a directional relay is a relay which will only operate if the current flows in a particular direction, and it will ceases to operate if the current flows in other direction. The detail of this definition we will see later on. So considering the constructional features of directional relay. What is a directional relay? As far as construction point of view is concerned, it consists of two units. The first unit is directional unit and the other unit is non-directional unit, or we can say it's simply a overcurrent unit. This is the diagram of directional overcurrent relay, which consists of directional unit. This is directional unit and this is the overcurrent unit. This directional unit is basically a 4-pole induction cup unit. This is a 4-pole induction cup unit in which two poles are fed with voltage and other two poles are fed with current. This is the two poles which is being fed by voltage, and this is the two pole which is being fed by current. Now voltage over here is considered as the polarizing quantity. What is polarizing quantity? Polarizing quantity is the quantity which will produce one of the two fluxes which is required for the production of torque, that we have already seen in our previous semester. That is the expression for torque production in case of induction relays. So and this polarizing quantity is considered as and taken as reference. So let us consider that also in this diagram we can see that if until and unless this directional unit contact are closed, this point, the overcurrent unit circuit is open and the shedding coil circuit is also open, so it will not energize. So in order the overcurrent unit needs to be energized, this directional unit contact needed to be closed first. Fine. Now consider at any situation or any condition that current flow in the normal direction at a particular direction. That particular direction is considered as normal direction. So the torque developed by the relay will be negative. The relay will develop a negative torque and it will not operate. And say for example, if by any mean the direction of current reverse, so the direction of current reverse, that means now the torque developed is positive and the relay will operate. Now consider now this is the expression for torque developed by directional unit, which is equals to T is equals to Vi cos theta minus tau minus K, where V is the maximum, or we can say the RMS value of voltage fed to the voltage coil, I is the RMS magnitude of the current, theta is angle between V and I, tau is maximum torque angle, it's a design quantity, and K is the restraining torque, which includes spring and friction. Say at particular installation, theta minus tau is constant and equals to K1. So the expression of torque becomes T is equals to K1 Vi minus K. Now under threshold condition, what is threshold? When the relay is about to operate. So under threshold condition, the torque developed is 0. So this is 0 and this is equals to K1 Vi minus K, and from this Vi is equals to K upon K1, which is equals to K dash and a constant. So this is the characteristic of a directional relay, which is known as constant product characteristic. This is the product V into I is constant. That's why it is called constant current characteristic, and it is in the shape of a rectangular hyperbola. So from the characteristic, it is clear that it is not enough to have this product greater than K dash, but there needs to be a minimum value of voltage and the minimum value of current which needs to be required. See, this is the minimum value of current and this is the minimum value of voltage. So if current lies within this minimum value, the relay will not operate. So in order the relay needs to be operate, the current required for the torque must be greater than the minimum value. Now consider this diagram, and A is the position of a directional relay. Now if the fault is close to this A, this location of directional relay, the voltage fed to the relay is less than the minimum value and the relay will not operate, and the distance up to which the voltage fed to the relay is less than the minimum voltage is known as the dead zone of directional relay. Okay. Now again consider the torque equation, which is equals T is equals to Vi cos theta minus tau minus K. Now in this phasor, this is V, which is our polarizing quantity which we have taken as reference, and the flux produced by this polarizing quantity is phi v, which lags behind v by an angle phi. This angle phi is basically in between the range of 60 degree to 70 degree, and this is the flux phi I, which is being produced by another quantity which is I. Now in order, and this the angle between, now in order the torque to be maximum, when the torque will produce, whenever this flux phi I will interact with flux phi v. Okay, so now in order to be the torque to be maximum, the position of this phi I needs to be on this dotted line. So now the angle between phi I and phi v is 90 degree, and the flux is and the torque developed is maximum, and this angle between this dotted line phi I and phi v, when it becomes 90 degree, is denoted by tau and is known as maximum torque angle. Considering the torque equation again, if v is fixed, or as we have already tell that v is a reference quantity and it is fixed, if v is fixed and neglecting k, we will get from this expression I cos theta minus tau is equals to 0. Now since I cannot be 0 for the production of torque, cos theta minus tau is equals to 0, or we can also write this as by eliminating cos, that is theta minus tau is equals to plus minus pi by 2 or 90 degree, or theta minus tau is equals to, or theta is equals to tau plus minus 90 degree. Now this is the polar characteristic of directional relay, which is obtained from this expression, that is, if in the region between, or the zone between this bold line and this dotted line is the zone of spring, and if the current lies in this zone, this is spring zone, the relay will not operate. So in order the relay will operate, it should be greater than the value, the minimum value of current, or it is clear that this region is the no operation region, and the region after this dotted line is operating region. Okay, thank you.